Hello students, in previous class we have studied about the electric current. In this section we will study what is potential and potential difference. Before to know about potential or potential difference, first we have to study some cases. Like suppose here is some water, some amount of water, and I want to take this water from this point or from this area to this point. Then what will you do? I have to make a hole here so that water can easily transform from one point to another point. Then how will you this water? What is the mechanism here? Here the mechanism is there is some amount of pressure exerted by the water in this tank due to its height. So it is transformed from this area to this point. Then similarly, in case of electricity, we have to create a pressure. We have to create a pressure of electric charge, so that it can or it can transform from high pressure area to the low pressure area. Suppose here is the electric cell. Suppose here is the electric cell. This is the positive end and this is the negative end. So what will happen? Generally here charge is created, large amount of charge is created, and it is transformed from this low or it is the neutral point. It is the neutral point. That means here is the no potential difference, or here is the potential is zero. You can say generally we rewrite it as positive and negative end, but it actually in the general line or home supply current there is positive end and there is the neutral end. Understand? So what will happen? Here is nothing. That means we can say here is no charge. Here is a large amount of charge. So what will happen? This large amount of charge will flow from this point to this neutral point, and if we insert electric bulb here, that what will happen? This will pass through, it will complete the path, or it will create a circuit so that the electric bulb will glow. There are a large number of that is examples which is based on this principle. Like suppose here is the bomb. How the bomb will damage to the other area? Here a large amount of energy is created inside the bomb, so that this large amount of energy will transform from this higher concentrated area to the lower concentrated area, so that this area will also be affected. Similarly, there is also another example, that is the lightning. Suppose in case of lightning, when the that is the negative end, that all the negative charges, all the in class 8 you have studied, so I don't want to explain it more, just recall it. And there is a large amount of positive negative charge, and here is the earth. And what will happen? This negative charge will forcefully it will transform from this section or from the cloud to the earth. So that lightning, that means there is a number of example in which there is anything transformed from higher concentrated area to the lower concentrated area. Similarly, in this 9 class also we have studied, that is suppose there is a water and I will add a drop of ink here. So what will happen? This ink will transform from this section to this one. Why it transfer? Because here is the high amount of concentration and here is the low concentration. Here is the no, you can say there is no concentration. If you consider it as electric charge, suppose here is positive end and this all these area are the neutral end. So what will happen? Now the charges are transporting from positive end to the neutral end. Similarly, the potential difference is equal with the pressure. Potential difference, we can say potential difference is similar to the thinking of our pressure. I think up to this you have and basic idea, that is what is the potential difference. So how will we define potential difference? Potential difference is the pressure created by the electric charge. But there is another definition. How we will define? Then suppose I will take another example, that is suppose here is a balloon. Suppose here is a balloon. Inside it, the air is compressed, so all the airs are applying pressure towards it. Then how will you know, or what is the amount of pressure here? We just want to we should press it so that in opposite direction, so that we can say that all the air are applying pressure. But if one air particle is here, it cannot feel the pressure. Suppose here is another, it feel the same. I mean to say that is suppose all these air particles will feel same amount of pressure in this area. That means here is pressure, but no pressure difference. We have to know that what is pressure and pressure difference. Pressure is inside this section, on all the air particles there is same amount of pressure is applied. But if you consider this air particle, we will say here is a difference of pressure. Here is large amount of pressure, here is a less amount of pressure, comparatively less amount of pressure. So here is a difference, pressure difference will create, so that if the balloon will explode, so what will happen? These particles will move towards this direction, or from higher concentration to lower concentration. So but my point is, that means here is if the potential difference is created, so that the electric charge can transform from one point to another point. But my point is, suppose my point is how to feel that amount of pressure. How will you feel? If I press it, I can feel the amount of pressure here. Similarly, suppose here is large amount of positive charge, or large amount of charge here. I am here saying that there is a positive charge, suppose. Then how I will feel the pressure in this section? I have to take, suppose I have a large amount of positive charge, or some amount of positive charge. How will I feel this how much this area is applying, or how much these charges is applying the potential difference? I have to take a single positive charge towards this area section, so that when I will take this, I will like the pressing the balloon, it will feel that some amount of pressure is created. Similar, that means we can define the potential difference as the amount of work done applied on a positive or single charge on a that is called point charge. Single charge is called as point charge. That means amount of pressure exerted on the point charge when it is taken from one point to another point. Suppose I will take this point charge or single charge from this area, or this point A to point B. How much difference between the point A to point B, or how much potential difference between these 2 points? I have to do some work here to take this try to take this, that is the point charge, to the point B. That means I have to do some work here. So it can be defined as the amount of work done required to take a point charge from one point to another point. Amount of work done required to take a point charge from one point to another point. It is mathematical, it is written as its unit is volt. Try to remember that it is volt. There is a scientist, Italian scientist, his name is Alessandro Volta. According to his name, that is the unit of the potential difference is written as volt. How will you mathematically, how will you define? It is defined as V equal to W by Q. Why I am dividing this? Because you are dividing the if you compare this with the mathematical expression of pressure, you can relate it. That is, pressure was P equal to F by A. Why F by A? Because amount of force exerted per unit area, per unit sections or unit area. Similarly, here is the suppose consider this as charges. Here are the charges, understand, and that is the force or amount of work, how much work we have to do to take a point charge from one point to that point. That is the amount of work done. So it is taken as amount of work done divided by area, means it is here is the how much or on each charges. That means there as the force is divided to each area, here work will divided to each charge. So it is as volt equal to W by Q, or V equal to potential difference equal to W by Q. So unit its unit is volt, and it is W unit is work done unit is joule, Q unit is or charge unit is, what is charge units? Charge unit is coulomb. So it is written as joule per coulomb or joule into coulomb inverse equal to volt. There is an electrical instrument, that is voltmeter, is used to measure this amount of pressure or this amount of how much amount of potential difference inside the wire or inside the two end, positive end and negative end. It is measured at voltmeter, and voltmeter is connected in parallel. Parallel means suppose this is positive end, this is negative end. A voltmeter is connected in this, like this, in this way. Understand why it is connected in this way? Because here is the large, here is not negative, here we will taking generally it is the neutral. So what will happen? Here is a high concentration or higher concentration, here is the lower concentration. So as current is flowing from positive to negative end, or from higher section or higher potential difference to the lower potential difference, how will you measure? If you put here is point charge, here is a large amount of charge. If you put we have to measure between, if you put something inside between them, or if you put voltmeter between them, so generally we connect it with positive end and negative end both. So it is from with positive end and its negative end. So it is taken as, it is as parallel connection. It is connected parallelly. Understand? Ammeter was connected in series, and but the voltmeter is connected in parallel. Understand? Try to differentiate between these two. Understand?